Welcome to the lecture series of Basic Electrical Engineering. Today, the topic is Principle and Types of Analog and Digital Ammeters. So, in this picture, you can see the ammeter. So, what is meant by ammeter? Ammeter is nothing but it is a device which is used to measure the current value. So, this is actually an AC ammeter which measures the AC current. This is actually a DC ammeter which measures the value of DC current. So here you can see volt also, it can be used as a multi-purpose meter. So generally, what is a meter? As we know, meter is associated with a measurement system. Meter which can measure a particular quantity. As we know, the unit of current is ampere. So it is nothing but a ampere meter. In short, we have named it as a meter. So in general, we can finally come to a conclusion. An ammeter is a device which is used to measure the current flow in a circuit. Okay, how to understand this analogy? So here you can see the ammeter analogy. So here you can see an voltage source. It is connected in a circuit of load resistance and ammeter is connected in series. Now we want to measure the flow of current in this closed circuit. We know already whenever the circuit is closed, the current will be flowing. Otherwise, the current will not flow. Similar to the water supply. So in the water supply will be flowing when the circuit is closed. Otherwise, there will be no flow of water. So similar to that, here we can relate this. So ammeter is similar to the flow meter. Okay, so whenever there is a drop or something opening here, what will happen? The water will flow, and the flow is measured by using the flow meter. Similarly, whenever the circuit is closed or some voltage drop is there, the current will be flowing in the circuit. That flow of current is measured by using this ammeter. So one point we have to remember, the ammeter is always connected in series of the circuit. The voltmeter may be connected in parallel. We might have studied that also. Here ammeter is connected always in series, similar to the flow meter. So in the voltmeter case, we might put a pressure gauge and we'll measure the pressure drop here. That is the voltage drop, that is known as the voltage. So here it is the flow of electrons, that is the flow of current, which is similar to that we are going to measure by this analogy. Okay, what is the working principle of the ammeter? So ammeter is nothing but it measures the flow of current. So it must have very low resistance and also very low inductive reactance. Why do we need this? Can't we connect an ammeter in parallel? So this may be a big question. Why should not be connected? Because the impedance of the ammeter circuit is very low, and the voltage drop across is also very low. So it should be connected in series because the current is same as the series circuit. Also, due to very low impedance, the power loss also will be low if it is connected in parallel. So it becomes almost short circuited path. So for example, if low resistance is there, what will happen? It is similar to the short circuited wire. So that the ammeter current will be more. What is the short circuit current? It will be more or very high. So that there is a chance of burning of the instrument. For this reason, the ammeter is connected in series. So once again we repeat, it has the very low resistance and very low impedance. So if it is connected in parallel, it is similar to short circuiting two phase and neutral or plus or minus. So what will happen? Dead short circuit will happen. The instrument will get damaged. So we have to make it in series. For ideal condition, the ammeter should have zero impedance. That is, there should not be no opposing force at all. But practically it is not achievable because some power loss will be there in the instrument. Okay, what is the classification of the ammeter? So depending upon the construction working principle, so ammeter can be classified in the following 5 types. One is the PMMC ammeter, that is a DC ammeter. Next one is the moving iron ammeter, that is it can be used for AC and DC. Further, it can be classified as a attraction type and repulsion type. Next one is the electrodynamometer type ammeter, which can be used for both measuring AC and DC. Then rectifier type ammeter, it is only suitable for DC measurement. And the final one is the digital ammeter. It may be AC or DC. Only one thing extra is required, that is A to D converter, analog to digital converter, and it should be programmed. So now we are going to see the PMMC ammeter. So the word PMMC is the abbreviation of permanent magnet moving coil. So here you can see two permanent magnet. Here one coil is there above the core or a wooden former. It is wounded, and this core is mounted over the spindle. This spindle is mounted over a pivot with a jewel bearing where it can be rotated freely, and it is controlled by the spring. That is the spring control, and the pointer in turn connected with the balance weight for balancing this pointer. And you can see a scale and mirror arrangement where the pointer can show the values. And here it is the next view. So in the parallel view, it is the radial field. You can see here. There you can see the spring control, and here you can see the coil and the deflection of the pointer. Little bit clarity picture here you can see. So there is a wooden former. In the wooden former, we have wound the coil. This coil is actually moving, so we made it as moving coil. In both the sides, we will be having two magnets. That's why it is known as a permanent magnet moving coil ammeter, and we will be having a scale, and this moving arrangement is connected in a pivot along with a jewel bearing where it can move freely, and it is connected with the hairspring which is made up of phosphor bronze so that controlling torque can be applied in it. So this is about the construction of the PMMC ammeter. So in the PMMC ammeter, how it will work? So in general of motor principle, whenever the current carrying conductor is placed in a magnetic field, a mechanical force acts on the conductor. So it is attached to a moving system with the coil and the point arrangement, so it moves over the scale. So as the permanent magnet is placed in both the sides, and it is suits only for DC measurement, and here the deflection of the pointer is directly proportional to the current in it, and if the current direction is reversed, the deflection of the pointer also will be reversed. So it can be used in AC. So it is one of the big question, why PMMC instrument is not used in AC. AC is nothing but alternating current. If the direction of the current changes, what will happen? The pointer will be moving positive negative positive negative positive negative, so there is no exact measurement. So it is only suitable for unidirectional quantities. That's why PMMC instruments are used only for the measurement of DC, and it works under the principle of de-arsenal type instrument. So that will be seeing in the later slides. So it has a linear scale. The scale will be linear, low power consumption because impedance zero almost, and high accuracy. The major disadvantages, it can be used only for the measurement of DC quantity, and the cost is very high. So here you can have a little bit clear view about it. Here you can see the permanent magnet former. Over that coil is wound, and it is mounted in a spindle along with the pivot and jewel bearing. Here you can see the spring control to produce the controlling torque. Here it is a balancing weight for the pointer. There is a pointer, and it is moving over a scale. So what is the de-arsenal movement? We can see that in detail in this animated form. So this de-arsenal movement is only for the PMMC or permanent magnet moving coil instrument. So it can be applied, or it can be applicable for de-arsenal movement. Why it is known as de-arsenal movement? Because it's invented by the scientist which is known as de-arsenal, so that it is named after the scientist. What is the de-arsenal movement? So here you can see we have a permanent magnet, U-shaped magnet. Here you can name it as a north pole, here you can name it as a south pole. In between these two permanent magnets, we are going to place a coil. So here it is the wooden former, here we are going to wind the coil. So the coil will be thick in nature, and more or less number of turns will be there. Along with that, there is a spindle. In the spindle, we are going to put a spring for producing the controlling torque, and also in the spindle we are going to insert a pointer. So when the supply is given to this coil, due to the interaction of these magnetic force, the conductor current, what will happen? It will produce a deflecting torque which tends to move the pointer from left to right. There is one more torque which is known as the controlling torque, which opposes the magnet force, so that it opposes the force of the pointer. Here you can see deflecting torque is proportional to I, that is the current. Controlling torque is proportional to theta. When TD is equal to DC, deflecting torque is equal to control torque, then what will happen? Equilibrium position will be attained. That is, theta is always directly proportional to I, so that we can measure the controlling torque here. So here, how the deflecting torque can be equated? So deflecting torque or force is equal to F, that is F is equal to BIL NB Newton meter. So here what is B? B is nothing but the flux density of that magnet in Weber per meter square. I is current flowing through the conductor or a coil in amperes. L is nothing but the length of the coil in meter. B is nothing but breadth of the coil in meter, because it is wound on a rectangular former, so it will be having length and the breadth. And N is nothing but the turns of the coil. So the force is always directly proportional to all these parameters. That's why we are getting the deflecting torque, and this is meant as directional moment. And how to extend the range? So the PMMC instruments are meant for only measuring the DC. So for low voltage DC it is applicable, but I want to extend the range. How it can be done? It can be done instead of buying a new meter, a higher amount of current can be measured by using only one additional feature. That is, you're going to only make one small change for measuring the higher currents. You're going to put a shunt resistance in parallel according to the range you're going to include. So this may be a simplest solution instead of buying the higher range of ammeter. So this type of meter is known as the extension range of PMMC ammeter. So here you can see I have inserted only one resistance in parallel to this meter. So I am having two resistance, one is RM, one is the RSH. So RSH is nothing but shunt resistance, and this is the total current. I is the total current flowing in this circuit. ISH is nothing but the shunt resistor current in ampere, and RM is the ammeter resistance. This. So due to this, we can extend the range of the ammeter. Next one, we are going for the moving iron ammeter. So in voltmeter also we may discuss about this. The moving iron type of instrument, it can be used for measuring both AC and DC, because the deflection theta is proportional to the square of the current. So whatever the current direction, it shows the direction of the deflection. So there is no drawback what we faced in the PMMC instrument. So there are two principles. One is the attraction principle, other one is the repulsion principle, and the torque equation is of I square dl by d phi. So L is nothing but the self inductance of the coil, and theta is nothing but the deflection in radian. I is the total current flowing in the circuit. So first we are going to see the attraction type MI instrument. So in the attraction type instrument, a soft unmagnetized magnetic field is placed. In that we are going to place a coil, and also here we are going to have a moving iron vane. This is known as the moving iron vane, and it is placed over a spindle. The spindle is attached along with the pivot and as well as the jewel bearing arrangement, so it will be moving easily and it can be controlled. In the previous case, the PMMC instrument were controlled by using the springs. Here, instead of springs, we are using the control weight as well as the balance weight to bring the pointer into an exact position. And here the damping used is the air friction damping the piston as well as the cylinder arrangement here. When the supply is given to this coil, so it acts as a magnet and it tries to attract this moving vane based on the value of the current or a voltage flowing in it. So here we are using as a voltmeter, so sorry, ammeter. So what will happen, based on this current, the force of attraction will be there, based on that the deflection will be there, so we can measure that. Here one more type is there, that is the repulsion type. Same here also we are having a one fixed vane and the movable vane. So when the supply is given to the fixed vane, it starts to ripple. So based on this rippling, the pointer will starts to measure the value. So in the previous case, it was the attraction principle. In this case, it is the repulsion principle, but both can measure the AC as well as the DC values. So, what is the advantage of the MI instrument? So, it can be used to measure both AC and DC. It is very cheap because no more copper coils are used or permanent magnet is used, and it has low frictional errors, and it is known for its robustness, and it is mainly used for AC measurement rather than DC measurement in order to avoid the errors due to the hysteresis. So this is about the moving iron instrument. Next one we are going to see is the electrodynamometer type ammeter. So here we are going to have two coils. One is the fixed coil and the moving coil. If current passes through the two coils, it will stay in the zero position due to the development of equal and opposite torque. So if somehow the direction of one torque is reversed as the current in the coil reverses, the unidirection torque will be produced. For ammeter connection is a serious one. So flux phi is equal to 0. Phi is nothing but the phase angle. So here the torque developed T is equal to I square dm. M is nothing but the mutual induction of the coil divided by d theta. They have very less hysteresis and it can be used for both AC and DC measurement. And the main disadvantages low torque weight ratio and high friction and expensive. So this principle is nothing but similar to the principle of the wattmeter. That is, two fixed coil will be there and one moving coil will be there, and the current is given to both the coils. Due to the interaction of both, will get the deflection. So this is the electrodynamometer type meter. So this is the construction here. You can see the fixed coil here. Both the fixed coils are there. One moving coil is there. This moving coil is mounted over the spindle with a bearing arrangement. And you can see the spring control over here. And this pivot as a pointer. This pointer is made to move over this scale so that we can able to measure the value of the current. So this is the electrodynamometer type. Next one is a rectifier ammeter. This is meant only for measuring the DC value. Here you can see the input value, that is the AC. Next one is the load. This is also AC, but here the AC is converted to DC and it is being measured by means of the DC ammeter. So the waveform in the ammeter is direct current. So it can be used for the purpose such as in the small charges, that is maybe laptop charges or some other charges, to measure the current which is in the form of AC. So here nothing is happening, only the current conversion is happening. AC current is converted to DC current and it is being measured. It is used for some special purposes but not for all the purposes. So here you can see it is connected, secondary of the transformer is connected to the bridge, that is the bridge rectifier, and in between we are going to connect a moving coil ammeter. So it can be used in high frequency also. It has uniform scale ranges. One drop is there, temperature decrease the sensitivity of the operation, that is during measurement of AC. And the last one we are going to see is the digital ammeter. So the digital ammeter, here you can see this is the ammeter with the digital. Here we have two extra components. One is the A to D converter. The analog value is converted into DC and it is programmed with the microcontroller. And we have the binary value, that is encoder will be there. That is BCD converter will be there. In the BCD converter, you can get the value in it and the 7-segment display. It may be used for both AC and as well as DC also. The next type of modern type of meter is nothing but a clamp meter, or other name is the tongue test. So here there is no electrical connection. If you the conductor is there, if you place in between these transformer clamps, due to the induction principle, we can easily able to measure the voltage, current, and resistance also. So especially to measure the current, it is go for the tongue testing. Just press this, open this mouth of the transformer clamps and keep in between the conductor, so you can easily measure the value of the voltage or current. This is a modern instrument which is used to measure current as well voltage and as well as ohm also. It can be used as a multimeter also by inserting this probes. So this is about the ammeter. In the ammeter, what is meant by ammeter, what is its analogy, and types of ammeters, in that we might have seen the PMMC instrument, moving ion instrument, electrodynamometer type instrument, and the digital type instrument we might have seen in detail. And also one more additional type we might have seen, that is the rectifier type ammeter. It is nothing but the special purpose ammeter used for measuring the current. Thanks for watching.